Hi guys, Frankenstein here. Let's check out also capacitors in parallel. So we're gonna start with the basic example where we have maybe a capacitor there. So let's have a battery there supply, and we have a capacitor there. And we have another capacitor, and that's my E. That's my C1, C2. Yeah, and then we have those two capacitors, and they want us to find same thing, Q total, number one. Number two, they want us to find QC1. Number three, they want us to find QC2. Number four, find VC1. Number five, find VC2. And what can we find as well? Can we find? I think that's all, right? I think that's all. Go to our capacitance. Yeah, that's all. It's calm. So let's find that. Now we're gonna start with the easiest ones, guys. Let's supply this 20 volts capacitance there. Let's say it's 2 farads. Let's say here it's 3 farads. Right? Now what they're saying to us is that we must find these 5 things which they want. So what I can say is that you must always check what is the easiest to find. But if I analyze according to the resistors, remember, resistors in parallel have the same voltage. Same thing with capacitors. Capacitors in parallel have the same voltage. So meaning I can find this section and also find this one. But now I noted that there's no resistor here. There's no capacitor here, which will be taking some voltage in series. So meaning that VC1 is equal to 20 volts. Number one. So another one is going to say that VC2 is equal to 20 volts because they are all in parallel with each other. So they'll have the same voltage reading because they're connected to the same node as the battery, all of them. That same node, which is the battery. Now we've cancelled these ones, so we've got to get those ones. Now let's find the total capacitance. The total capacitance is weird in series. So in parallel, Q total in parallel, you use the series formula. So you're gonna just say C1 plus C2. So basically the new formula I'm introducing is that if you have them in series, your formula is gonna be Q total is equal to C1 plus C2 plus Cn until, and this is under parallel conditions. Is it fine? Okay. Now let's check how can we find it. So it's gonna be equal to C1 is 2 plus 3. So we have 5 farads is our capacitance, our total. What did I say? QT? CT. I saw that I was missing something. Let's replace that with CT. Sorry guys. Replace that with CT. And what formula did I say there? Let's drag that back. Yeah, I take that back, guys. I take that back. I'm sorry, guys. So the new formula I'm choosing is that CT is equal to C1 plus C2 plus Cn. Now that is under parallel conditions. And what we can say as well again is that the total capacitance will be this, and that's the question I'm missing actually. So looking for C total, right? Now we got that. Now let's look for the total charge, right? Total charge. Remember I said total charge is equal to what? So QT is equal to CT multiplied by E, right? And that originates from Q is equal to CV. So meaning that CT is equal to what? C2 just found it's 5. What is E? It's 20. So 5 multiplied by 20. So our answer is 100 coulombs. I managed to answer that. And total capacitance. Now what we're left with is finding the charge of C1 and C2, right? How do we do that, right? There is a trick, but I'll show you the trick on the next video if you come back to the next video. So I want the charge. Remember, there's a formula which says Q is equal to CV, right? So to know the charge of QC1, I'll say QC1 is equal to C1 multiplied by VC1. What is C1? C1 is 2. Now, what is the voltage of the voltage of the capacitor there? C1 is 20. Remember the N parallel, so it's going to be 20. 2 multiplied by 20 is 40 coulombs, right? Okay, fine, we've got that answer. Now let me remove this one here in the bottom so I can just squeeze it in just a bit there, because I'm gonna need to compare this with answer when we're done. Okay, let's do it here on the bottom. So meaning that QC2 is equal to C2 multiplied by VC2. Now QC2 is equal to C2. What is C2? C2 is 3 multiplied by, what is VC2? VC2 is the same voltage among these capacitors, so it's going to be 20. And then that multiplied is equal to 60 coulombs. And what you notice is that this charge plus this charge will give you the total charge. Because remember, the charge will come here and some will go there, but after that they will meet here and become total again, because here they were total and they split it here. So that's what we can get from this. So yeah guys, thank you guys for tuning in. I think this will be the only example, and then next videos will be just broad examples.